its shape.
Those cracks actually just mean that the helmet is doing its job.
Modern motorcycle helmets are complex bits of engineering. They need to protect the rider in all kinds of crashes, but they must be light, offer good visibility, be comfortable, aerodynamic, and act as a sound dampener. That's why designing a new helmet can take between 2 to 3 years. Here, a researcher is testing a new helmet in an acoustic wind tunnel, which is used to gauge aerodynamic performance and noise levels. This tunnel can generate gusts of up to 230 kilometers per hour. It's like an indoor cyclone. Wind noise is a serious threat to a motorcyclist's hearing. Without protection, at 100 kilometers per hour, the driver would experience up to 100 decibels of noise just from the wind. Prolonged exposure would deafen you. Using the wind tunnel tests, Schubert have been able to reduce noise levels in their helmets by 15 to 20 decibels. It's also important for a helmet to be aerodynamic. At 200 kilometers an hour, a poorly designed helmet exerts the same drag force as a 10-liter bucket of water hanging off the back of your head. So, back in the lab, a thin line of smoke is used to show how the air streamlines around the helmet. Experts can see how the airflow shifts when the wind changes direction or the rider's head moves. The other problem is bad weather, greatly increasing the risk of an accident. So a new helmet design must be put through its paces in a rain tunnel to see how it copes. The results of all these tests are then fed into the computer, and the designers are able to make subtle alterations to the shape and structure of the helmet. After testing and tweaking and more testing, the new helmet design is finally sent to Schubert's assembly plant, an hour away in Magdeburg. Production begins with reams of fiberglass cloth. It may seem strange, but this cloth will soon be transformed into the incredibly tough outer shell of the helmet. The high-carbon steel knife follows a pre-designated pattern, slicing through up to 15 layers of fiberglass cloth at a time. The secret to making the fiberglass strong is hidden within this molding press. Forget robots. At this stage in the process, every helmet is made by hand. The cloth is placed carefully around the walls of a mold. Then resin is used to coat the inside of the cloth. Then a lid with a silicone balloon is lowered. The balloon expands, forcing the resin and cloth against the walls of the mold. The whole thing is then cooked at 80 degrees Celsius. The heat causes a chemical reaction, fusing and baking the resin and the fiberglass, turning flimsy cloth into an incredibly tough casing. The shell is ready, but it needs a haircut. For that, they use an extraordinarily accurate and powerful jet of water. The helmets are loaded and locked into a kind of vise called a jig. They're then swung round into an enclosed cutting booth. It's then safe to turn the water jets on. Each water jet is cutting with a pressure of over 50,000 psi. That's 2,000 times more pressure than you'll find in your car tires. These jets are so powerful, they can cut through granite, marble, and steel. Fiberglass is child's play. Water jets are used because they are as precise as a laser, but they don't burn the fiberglass. They produce almost no dust, and they never wear out. The robot cuts the outline of each helmet, then carves a series of holes, at the top for ventilation and at the sides for the attachment points of the visor and chin guard. It takes just 30 seconds to cut 2 helmets. The next step is to sand off all the bumps and ridges using mini sanders before the helmets are painted, again by robots. The paint is flash-dried under ultraviolet light. Now the outer shell is ready for final assembly. A rider's life depends on the helmet, So each helmet is assembled meticulously by hand. It takes 20 minutes to put a helmet together. Time for the protective inner shell. The cheek pads, the chin guard, some neck protection, and the visor. A last check to ensure everything is working smoothly. And the helmet is ready. Even the most cautious motorcycle rider can't be sure they won't be involved in a terrible accident at some point. But they can at least get ahead of the game with a well-engineered crash helmet. Behind the ordinary is the extraordinary. Coming up, the epic story behind the humble rubber band. There's something very strange about these two men. These San Francisco brothers are on a mission to make the largest ball of rubber bands the world has ever seen. It's taken them 6 years so far. They've tied together almost 1.5 tons of rubber bands to date, and they say they sometimes work as many as 11 hours a day. We had to ask them why.
I have high blood pressure. When I work on it, it goes down.
Man has been playing with rubber for thousands of years, and despite the invention of synthetic alternatives, nothing is quite as elastic as natural rubber. The great rubber plantations of Segambut, northwest Malaysia. The hot, wet tropical climate here is perfect for growing all kinds of exotic fruits and is also ideal for rubber trees. The bark of the tree is delicately sliced diagonally. And from this 5mm deep gash, a white liquid slowly dribbles down. This milky substance is latex. Each tree produces about 50 grams of latex every time it's milked. The challenge now is to turn runny latex into springy rubber. First, the latex is filtered to remove impurities, such as leaves. Then it's mixed with acid in these baths for 10 hours to solidify it. Then the latex is fed through a mangle in order to remove the excess acid and water. The latex is shredded, leaving it looking like overcooked scrambled eggs. And then it's heated in these huge ovens for 13 minutes. It emerges looking like a sponge cake, and it's ready to be compressed into blocks which will be shipped abroad. The latex cakes finally make their way across the world to Hot Springs, Arkansas, hometown of the young Bill Clinton, and also the equally elastic Alliance Rubber Company. Its annual output would stretch from the Earth to the Moon and back 5 times, or as far as Mars if you pulled really hard. Here, as in San Francisco, rubber exerts a strange hold over people. This guy doesn't feel dressed unless he's wearing one of these fetching rubber suits.
Probably the main thing that I like really about it, it helps keep my weight under control. You know, I can shed a few pounds off real quick. And of course, if I put on a few pounds, she stretches right along with me.
But not everyone here is quite so enthusiastic.
Actually, some people, you know, it's a fantasy just to have a rubber suit and dress up in rubber. They like to feel a rubber up against them. Not me. I like to feel a rubber on my hands and that's it. I like polyester and cotton.
The latex is halfway to becoming rubber, but it's not yet strong enough to make a rubber band. It has to undergo a process called vulcanization. For this, you need a cocktail of chemicals.
Mostly add a little sulfur and a lot of other magical ingredients to make it come out to be a rubber band.
The rubber is fed into a mixing oven. The chemicals are added, the materials are kneaded together and heated, and the rubber is turned from soft dough into the elastic form which we recognize as rubber. When the rubber reaches 120 degrees Celsius, it's dropped onto a giant rolling pin which cools and rolls it into strips. Then a machine called the extruder shapes the rubber into a hose, ready to be cut into bands. On this line, 3,000 rubber bands are cut every minute. Once the rubber bands have passed quality control, they're packaged and sent to Nabil and Samir in San Francisco. it just gets bigger and bigger.